the periodic table. This is the periodic table. There really is no more useful tool for getting your head around chemistry. It lists all known elements arranged in different groups to help us make sense of their properties. The key thing to remember is that an element's group number is the same as the number of electrons it has in its outer shell. Now, an exception to this rule is the noble gases in group 0, who have a full outer shell of electrons. But because of this rule, all elements in the same group react in a similar way. So the atoms of group 1 elements all have one outer electron. The atoms of group 7 elements all have, guess what? 7 outer electrons. Group 1 elements are called the alkali metals. They're soft and shiny when freshly cut, but they quickly tarnish as the metal reacts with oxygen in the air. This is because they're very reactive. When a group 1 element reacts with water, it produces a metal hydroxide solution and hydrogen gas. Let's try it with lithium. So on with eye protection and gloves. Here I've got some lithium, and then I'm just going to cut a little bit off. And you see how quickly it tarnishes, how quickly it's changing colour. Here we've got some water, and if I put some universal indicator in, like this, you'll see that it's green. And that means it's neutral. But let's see what happens when we put the lithium in. Well, you can see it's reacting with the water straight away. It's steadily fizzing away there. It's transferring its energy to its surroundings by heating. And can you see the little purple trail there? That universal indicator is showing us that the water now contains an alkali, in this case, lithium hydroxide. So let's try it with another group 1 metal, sodium. As you can see, it reacts far more vigorously than lithium. Why is that? Well, sodium is below lithium in group 1, and the reactivity of the alkali metals increases as you go down the group. So potassium is even more reactive. Whoa, look at it. Remember, group 1 atoms have 1 electron in their outer shell, and when they react, they lose it and form a positive ion. As you go down group 1, the atoms have more shells of electrons, meaning the outer electron gets further away from the positive nucleus. It's easier to lose, and that means the metal becomes more reactive. Group 7 elements are reactive nonmetals called the halogens. They exist as diatomic molecules, 2 halogen atoms joined by a covalent bond. They are fluorine, a very pale yellow gas; chlorine, a pale green-yellow gas; bromine, a red-brown liquid; and iodine, a shiny purple-black solid. As you go down group 7, the elements become darker. At room temperature, they go from gas to liquid, then solid, because their melting points increase. You can compare the reactivities of halogens using displacement reactions. A more reactive halogen can replace a less reactive one in its compounds. Chlorine is more reactive than iodine. Pop some chlorine solution into potassium iodide solution, and the mixture changes to brown as iodine is displaced, and colourless chloride ions form. The atoms of group 7 elements have 7 electrons in their outer shell. They share one with another atom to form molecules. In reactions, each atom gains an electron to complete its outer shell, forming a negative ion. As you go down group 7, the reactivity of the elements decreases. The atoms have more filled electron shells, so the outermost shell gets further from the positive nucleus, and it's more difficult to attract and gain an electron. And of course, groups are just one aspect of the periodic table. It's amazing how much information is in it. It really is elementally powerful.